Hello everyone, welcome to this video series on database management system. So in this video, we are going to discuss about decompositions. Okay, so you are going to see why do we decompose the tables, and also while decomposing the tables, what are the things we need to take care of. Okay, so let's start. So I already told you in the normalization video. So if you didn't watch the normalization video, first go to the normalization video. So the link to the playlist is in the description below. So you can click the link and see the video on normalization. So what happens in normalization is, first, why do we do normalization is to reduce redundancy. Okay. So typically what do we do to reduce redundancy is we take the large table that we have and we divide it into small tables. Okay, so this division of large table into small tables is called as decomposition. Okay, right. Now typically what do we do in decomposition is, so if you see here, whatever attributes you have in the big table, let's say there are 4 attributes A, B, C, D. Now you are dividing this table into, let's say, 2 tables. So in one table there is A, B, C, 3 attributes, and in the second table you have C, D. Okay, so you take the set of attributes, 4 attributes, and you divide it into subsets. Okay, so that is what is mentioned here in this point. Now let's see an example. So we are going to look at a tabular schema R with some FDs. So it is like this. Okay, so you might have remembered this table from the first video, that is schema refinement, right? So this is the table, its name, let's say its name is R. Okay, so it has 1, 2, 3, 4, 5, 6 attributes, and let's say EID is capital A, ename is capital B, and so on. Dname is capital F. So I just renamed the attributes to A, B, C, D, E, F, and let's say these are the FDs that are there on the table, functional dependencies. Okay, so there is a functional dependency from A to B, and there is a functional dependency from A to C, and there is a functional dependency between E to F. Okay, and in this table, EID is the key, primary key. Okay, right. So as I told you, EID is the key, and right. So by looking at this FDs and this table, can you tell me in which normal form this table is in? Okay, so let me explain to you. So it is already in first normal form. Okay, so no column is having any multiple values. Each column is having only one value. For example, ename here in the first row has Ramesh. Okay, like that. In the experience, there is only one value, 2. There are no multiple values. So this table is in first normal form. Is this table in second normal form? Can you tell me by looking at the FDs? Okay, the answer is yes, it is in second normal form. So what is the primary prime attribute in this table? Only one attribute is there, EID. So whenever the table has only one attribute as the key, that is in the candidate key, so the table is already in second normal form. Okay, right? Second normal form is violated only when there are partial dependencies. When you get partial dependencies, only when you have composite key, that is the key is having more than one attribute. Here there is only one attribute, so there is no problem, there will be no partial dependencies, so the table is in second normal form. So is this table in third normal form? Okay, so this FD satisfies third normal form, and this FD satisfies third normal form. Why I am saying these to satisfy third normal form? Because the LHS is already a super key. Okay, what about this one? This FD does not satisfy third normal form. Why? Because the left hand side is not a super key, and the right hand side is also not a prime attribute. Okay, so this table is not in third normal form, and hence, because it is not in third normal form, it is not in BCNF also. right? Okay, so you can see the FD E2F violates third normal form, just like we explained, and also because it is not in third normal form, it is also not in boys code normal form. Now, since this table and the given FDs violates third normal form, we will decompose the table. Okay, so we are decomposing the given table R into two tables. One table is having the attributes A, B, C, D, E, and the second table will have the attributes E, F. Okay, so this is the first table. Let's say this is R1, and the second table will have, let's say this is R2, two attributes C and F. Okay, and also in the second table, that is this one, E, the attribute E is key. Okay, it is key in the second table. So let's see the two tables. So here are the two tables. This is R1 and this is R2. Okay, so in R1 we have 5 attributes A, B, C, D, E, and in R1 we have 5 attributes A, B, C, D, E, D, E, and in R2 you have 2 attributes E and F. When you do R1 union R2, you should again get all the attributes which are in the original relation R. So if you combine these two, you will get again the attributes A, B, C, D, E, and F. So this decomposition is okay, right? What about the FDs? We have 3 FDs, right? These 3 FDs. Now, how do we divide those FDs? So like this, R1 gets first 2 FDs and R2 gets the third FD. Okay, so can we write E2F here, this FD here? You can't write. Why? Because F is not there in this table, so you can't write this one in R1. Okay, it belongs to R2. Similarly, I can't write these two things here because A, B, C does not belong to this table. They belong to R1, right? Okay, so we can say that the FDs A to B and A to C are preserved over relation R1, and the third FD E to F is preserved over relation R2. So just focus on this term preserved. I will talk about this in the coming videos. This is very important. Okay, I have simply written that these two FDs are preserved over R1 and this FD is preserved over R2, but actually we have to check whether it is happening or not. That procedure you will see in the future videos. Okay, all right. Now this bottom point is very important, because whenever you want to decompose one table into 2 or more tables, you can't do it as you wish. Okay, so you have to follow these two things. So you have to check whether the decomposition you are doing is following these two properties. So first property is the decomposition should be lossless, and second property is the decomposition should be dependency preserving. Okay, so we call them as lossless decomposition, and second one we call it as dependency preserving decomposition. So I am repeating again, whenever you decompose large table into 2 or more tables, you should see that the decomposition is lossless and second one is dependency preserving. Okay, so I am going to stop this video here. In the next video I am going to explain what is lossless decomposition along with examples. Okay, so if you I request you to like the video and also share it, and also if you have any doubts, please comment below the video. Thank you.